In this video, we'll be looking at counting and probability with letters. For the first example, we want to find the number of distinguishable permutations of these letters. Now, the fact that these letters spell the word bookkeeper is actually irrelevant. We just want to know how many different ways can we rearrange those 10 letters and have it look different. So, for example, I can switch around the K's and it doesn't make any difference. That would look the same. So that would not be distinguishable if I were to switch the K's. So what we want to do to start off is find the total number of ways in which we could rearrange these 10 letters. So if I have 10 spaces to put letters, and I have 10 letters to put in them, I have 10 ways to choose the first letter, 9 ways to choose the second, 8 ways to choose the third, and so forth and so on. So I would have 10 factorial ways to rearrange these 10 letters. Now, some of the letters are the same, however. So some of the ways in which I can rearrange letters are actually going to look the exact same. And so what we need to do is divide out the number of ways in which we can rearrange the letters and it actually not look any different. So if we look back at the K's, they can be arranged in the order they are currently, or we could switch them, and that would be two different arrangements that are actually not distinguishable. So for any arrangement of these letters, where there are two K's, we can swap the K's and it would be not distinguishable. So what we need to do is divide by the number of ways in which we could rearrange the K's, and the number of ways in which we could rearrange the K's is 2 or 2 factorial. Then we want to look at the O's. So we have 2 O's. We have the same thing here. There are 2 ways in which we could rearrange those O's for every arrangement of those letters. So that's another 2 factorial. The other repeated letters we have are the E's. So we have 3 E's, and so for any arrangement, those 3 E's can be arranged in a number of ways that would not be distinguishable. So the number of ways in which I can rearrange 3 objects that all look the same would be 3 factorial. So to solve for this, we would do 10 divided by 2 factorial times 2 factorial times 3 factorial. And what we would get is that we have approximately 151,200 different ways that we can rearrange those 10 letters that all look different from one another. Let's look at another very similar example. If the following letters are arranged at random, what is the probability that they actually spell the word bookkeeper? So, again, since this is a probability, we'll have a numerator and denominator. The denominator would be the total number of ways in which we could rearrange those letters. So there's 10 letters. The total number of ways in which we could rearrange them would be 10 factorial. And in the numerator, we want the total number of ways in which we can spell the word bookkeeper, including the number of ways in which we can rearrange the letters and it still spell bookkeeper. So for example, I could switch the O's, it still spells bookkeeper. I can switch the K's, it still spells bookkeeper. I can rearrange the E's in a bunch of different ways, but keep them in the same places, and it would still spell bookkeeper. So the number of ways in which I can rearrange the O's is 2 factorial. The number of ways in which I can rearrange the K's, another 2 factorial. And the number of ways in which I can rearrange the E's is 3 factorial. So the numerator would tell us the total number of ways in which we could spell out these letters and spell the word bookkeeper, divided by the total number of ways in which we could rearrange those 10 letters. So what we get when we calculate this out is about 6.6137 times 10 to the negative 6th. And so we could write that out in decimal form as 0.00000066.